welcome to the Advanced Air Mobility session. It's my extreme pleasure to welcome Dr. Anna Straubinger. Anna's a transport economist and is joining us from Germany, and it's 2 a.m. in Germany, so look, fantastic. I know that you've pushed on through to this time, so thank you. Anna is a postdoctoral researcher at ZEW Leibniz Centre for European Economic Research in Mannheim. And Anna studied transport economics with a focus on transport policy and spatial economics at the University of Dresden. And then from 2017 to 2022, she was employed as a researcher in the economics and transportation team of the Interdisciplinary Aviation Research Institute, Luftfahrt EV. So in parallel with that, from 2017 to 22, she's pursued her doctoral studies as a PhD candidate in the Department of Spatial Economics at Minnesota University of Amsterdam. And the dissertation used urban equilibrium models to investigate the long-run effects of urban air mobility on households and the environment. So an awesome person to have on this session, Anna. And you've got a number of journal publications out there, so which have got really interesting article names as well. So I might pop those up a little bit later on. And also, the rock star of the Australasian scene, I'd say, from everyone knows Catherine MacGowan. She's the director of Asia Pacific Wisk and is on the Wisk executive team. She's been prolific today already and has been on a panel and given a presentation. Wisk have just unveiled, as we know, their Gen 6 all-electric self-flying air taxi. Wisk is based in the US and New Zealand and backed by the Kitty Hawk Corporation and Boeing. And Boeing's an investor and a strategic partner. So Kath was a group captain in the Royal New Zealand Air Force, where she held a number of leadership positions, did a great job there, and also worked several years in the middle there for the Ministry of Primary Industries. And look, there's also a bit of an academic, has gained a master's with distinction. So great to have you both on this. A little bit about myself. I'm a consultant. I've got about a bit over 30 years involvement in the civil and military aviation as a pilot of helicopters and fixed wing, and also I've dabbled in the unmanned sector since I left the military in 2017. So I'm instrument-rated on helicopters and fixed wing, and I've been involved in advanced air mobility city planning for a massive city in the Middle East. UAVs and operations in a mesh network. I do a bit of safety management and risk management. I think interesting for this call, I do heliport assessments and developments, which looks at the vertiport and skyport structure, infrastructure that'll be required, we'll touch on. And I'm part of the Vertical Aviation Safety Team Regulations Working Group, which is based around safety, so that's an international group. So look, we're going to take a slightly different approach to this from other panels, and previous panels have had the panelists doing presentations and then coming together at the end. So I thought we got together last week and thought we might talk through just our areas and more of a conversation with the three of us. So there is a poll out, and the poll I'll talk to second in a moment. So no PowerPoint presentations, as I said, and there will be Q&A. So if you do have questions that you'd like to pose to the panel or throughout as we talk through this, please do pop them up there in the Q&A area, and we'll do our best to weave those in. So poll, what's the biggest challenge with the introduction of advanced air mobility? And is that certification standards? Is it regulatory requirements? Is it infrastructure? Is it public acceptance, user adoption, stakeholder alignment? And I sort of regret putting the last one in, which is all of the above, because that's an easy out for people to use. So it'd be great if people were a little bit more selective than number 6, but probably has a reasonable amount of applicability. So just to start the session, I thought we'd ask Anna to, considering she's popped out a PhD in this, but we'll start off with Anna. So we're looking at what is advanced air mobility, and is it the same as urban air mobility? How do you see that?
Yeah, so first of all, thanks for having me today. And so I think the definition of advanced air mobility is quite interesting, because if you look into the literature, there's a lot of different definitions on it. And I think we all agree that it somewhat is a novel kind of air transport that allows you to transport people or cargo in an affordable and safe manner with a high level of automation. And all of that allows you to take it into urban areas and rural areas. And I think that is already where the definition of, or the difference between urban air mobility and advanced air mobility comes in. So that is where people started from. So they said, well, we're going to take it into urban areas, but I do believe that now the developments have been advancing and people now rather believe it's going to be a broader set of application cases that we're going to see. So we're going to see, well, inner city transport, but also transport between cities or in rural areas, or kind of regional transport. But I think what all of them have in common is that we think it is going to be electric. We might have application cases where we see hydrogen or other kinds of, well, be it sustainable aviation fuels or something like that. And I think that is where all of that fits together, and we're going to see bigger vehicles, smaller vehicles, and I think that is like still in development. But
a follow-on ecosystem. So it's really is the heart of that automated, or can you sort of see the? I know that you believe that sort of Wisk is going straight to the automated air transport or air taxi as a piloted version. Is that advanced air mobility as well, or is that?
So that's an awesome question. So the way we see the advanced air mobility industry is in the integration of all of these technologies. So we think what will come to market first is the piloted platforms, because they have a lesser regulatory and sort of infrastructure development hurdle to get over before they come to market. So about the middle of the decade or second half of the decade, you'll start to see, you know, the smaller ones with the short ranges with a pilot, and then we'll gradually introduce that platforms like Wisk that are self-flying. And so I think one of the key characteristics of this, you know, sort of future AAM, UAM environment is the integration of piloted and self-flying aircraft, because there will always be a need for piloted platforms in this landscape. So the future will be needing to have systems that allow them to work alongside each other, along with the other features that Anna's talked about.
So, and also that, moving on to what are the use cases you see for advanced air mobility?
So I think if we're talking about the use cases, there are three different kinds of fields that we should think about. We should think about where are we going to see this happen? What do we think is going to be, what services are going to be offered, and how are they going to be offered? And I believe, especially for the question of where, I think it's important to think about, well, geographical specificities that somewhat lead to like making air transport more efficient in one way or the other, be it mountains, be it rivers or lakes that you can simply fly over, or it could be regions in which you don't have that much ground infrastructure for transport, for example. And then if we think about what is going to happen, so what are we going to see? Is it rather going to be a touristic use case? Is it going to be emergency services that we're going to see? Or, for example, airport integration? That is one of the big topics that we always hear when we're talking about passenger applications. And I think the last part is how is the service going to be brought to us? Is it rather going to be a point-to-point thing? Is it going to be a hub-and-spoke network? Is the service going to be scheduled, or is it going to be on demand? So there are a lot of open questions still, but I think these are the three levels that we should be discussing when we think about use cases for advanced air mobility.
Catherine, what's your view on the use cases?
So similar to Anna, right? I think there's going to be a range of options, and I think we don't even understand now all of the things that we'll be able to use this industry for. Wisk is very much focused on the congestion issues, so things like airport shuttles moving across, you know, significant cities like LA, where the time to drive is long and also unpredictable. So bringing kind of predictability and speed into people's transport plans. But I think the thing about this kind of capability is it sits well alongside other investments in transport, whether that's fast rail on the ground, whether that's other forms of AM for emergency rescue services. So you start to see the future transport landscape as being, this quite integrated grouping of, services like Wisk, which is sort of that scheduled or on demand that someone might use a couple of times a week for a specific activity, to reach a medical or a learning facility or travel to an international airport. But the rest of the time they might be able to use fast transit. And so overall, you're seeing a transport landscape with high levels of utilisation and lower levels of individual ownership as we move towards, hopefully more and more towards decarbonisation.
Yeah, so massive integration, right? And that seems to be the word. So as you look at the macro and the micro part of it, and I suppose from a consulting perspective, it's really difficult because this is in its infancy. And so understanding exactly where those use cases are going to be, you're sort of throwing darts at the dartboard and sort of beach combing the Google pages, for want of a better word, to sort of try and get that in, and then apply it to the problem at hand in those cities, which is definitely, in the city that I'm thinking in is, it's growing by 1 million people a year at the present, and that's has massive issues for the transportation around the city and the economic prosperity. It's a bit of an economic handbrake when you've got massive congestion around the city. So how do you see that being integrated, when you are looking at from around an airport perspective, Anna, like integrating these air taxis into the airport environment?
So I think the airport integration use case is an interesting one, because what we know is that it's difficult to fly into, airport surroundings in any kind, because you don't want to affect the throughput of the airport for conventional airliners. So you need to find a flight path that somewhat fit the approach paths of the conventional aircraft. And that is something that I think is going to pose severe risks, because especially if we think about where are we going to locate the vertiports at airports, we need to understand that we don't want people to have to change to a bus or a shuttle service to then get to the terminal. We want them to be close to where they then want to fly from, or where they will land at the airport. So I think that is one of the main drivers when we think about airport integration, that we need to make sure we find a location at the airport that is close enough for the to make it really attractive for the passenger.
Mm-hmm. Yeah, and I've sort of grappled with that a bit as well. I think, if the helicopters going into the airport environment, they fly a lot slower than the airliners, and so generally come in that terminal area outside of the instrument approach and departure sector. And so you're 90 degrees out from the traffic flow and a lot lower. And so that part, I think it's going to be unavoidable to get those aircraft into a spot that then has to take another mode of transport to get into the terminal area. And I suppose, the airports where this use case is applicable do already have the intra-terminal transportation, whether it be by train in and around there. So that might fit into another part of that transport. And hopefully the automation will be so good that actually you can integrate and fly them straight on top of the terminal building without the geofences that we have just with the small drones, be able to apply that same concept, so you have some sort of guarantee that it's not going to interact too much with those airliners taking up and landing. Which sort of leads on to the sort of the safety element of this and integration. And we look at IT projects and large projects with lots of different stakeholders and requirements, and integrating all of that. So it provides some massive challenges, as sort of we've highlighted in the poll that we've got going. But how do you see how integral? Well, safety is going to be integral to this. How do you see the safety element of this going or developing over the next few years?
Yeah, so important. So safety is something, as you can imagine, we talk about a lot. So there's a few layers to this. There's the there's the design level of the aircraft and the other sort of what we consider critical aviation components of the capability. So those that have had to listen to me twice today, we talked this morning around, you have the aircraft certified under Part 23, but also elements of the Fleet Operations Centre. So you're providing that level of assurance to the regulator. Then in terms of the operation as well, so as we look for a Part 135 or equivalent in other countries certificate, you have to show that your operation is safe. So that's where, we'll be operating IFR and eventually DFR. So showing the way that airspace integration, separation standards, latency, contingency behaviours, all of those things fit into the operation day to day is important. Then there's also, sometimes I'll say we're building an aircraft and an industry and a company. So, we're establishing our safety management system inside of Wisk as an OEM. And some of you will know Merv Hughes, who is part of that team at the moment. So a lot happening there to ensure that we have the culture in place, just culture, all of the processes. And then, this has come up several times already today, we have to design to be safe and know that we're safe from an aviation perspective, but then we also need to translate that into terms that the public can understand. So they, understand what is the trusted authority that has checked the system is safe before I fly on board. How is it monitored? How do I know if something's happening? How do I know to be concerned if I can see aircraft around me out of the windows? So, I think there's a lot of pieces of that. And just one thing to close on there is, I think, over 100 years, we've built out an entire safety system, and we've come up with a whole lot of ways, a lot of concepts like minimum runway occupancy and our separation standards. And as we move towards AAM and especially autonomy, we need to build in new and different safety systems, but we need to build them together. Yeah, so very important.
Yeah, it is. And look, I was fortunate enough a couple of years ago to attend in the States a conference on how the certification standards are going to be developed. And so the only area that I really know is the sort of Federal Aviation Regulation standards. So there's a FAR 23 and FAR 25, which is sort of for the fixed wing, and then there's FAR 27 and FAR 29 for helicopters. And so none of those really apply wholeheartedly to this advanced air mobility. And so the development of these vehicles is really difficult. So they're developing them and then create the creation of the standards, which is very akin to how normal aviation has sort of developed. And I really liked, I saw Dicko earlier on, Richard Beaton, talking about the past where there was an environment that was unregulated and trial and error, which created, there was a lot of fatalities, and but there was a surreal romantic following for aviation, and accidents and incidents were accepted, and that has changed. The environment that we live in now doesn't accept that at all. So the certification standards are sort of integral to the first, or so I suppose that first step, that getting that right will then enable the regulatory, which sits side by side, get those two things right, and everything else seems to flow. Would that be a fair sort of statement?
Certainly hope everything flows. But yeah, so Wisk platform we certified under 23 17B, and so it's really interesting. And actually, FAA has just published Joby's G1, if people are really interested in how that looks in practice. So obviously it means that there's a powered lift category, and we'll be looking at, what are the means of compliance or exemption, which of the rules do we bring together. And I think one of the, I think those standards are so important, but one of the interesting things for the community, and we spoke about international harmonization this morning, is that obviously the approach FAA and EASA are taking for this industry, is a different way of achieving the same result, safe advanced air mobility, but that that can mean for other regulators, say around Asia Pacific, that they have two different philosophies to understand and work with. So I think, you know, the global regulatory community working together to create that international harmonization so that platforms can be moved across different jurisdictions is a really important enabler, because what we don't want is for there to be kind of an Apple-Android split around the globe.
Yeah, and Anna, you're based out of Europe in Germany, so you know that you live in the heart of sort of this mixing bowl, which is the European Union, and coming to consensus and developing that sort of stuff. I suppose you're aware, or it'd be great to get your perspective on, is that an easy process because you're used to it, or is it still a difficult process to get to a consensus?
Well, I think it's difficult. I think one of the main points is that we have all of the different OEMs here in Europe, and all of them have also different vehicle concepts. That's what we see all across the market. So we have all these different configurations, and they all, of course, work together with the regulators. But that, of course, makes it harder. And then there are different interests from different countries. So I think that doesn't make things easier. And I very much agree that we need to make sure that it is a global solution, and it's not only a solution for the American context and then for the European context, because I think aviation in general is a global system, and I think we shouldn't think that the advanced air mobility system is going to differ in any way from that.
Yeah, it's sort of a race to get off the start line, isn't it? So the first one that gets underway using a particular system, sort of that will probably trump the other system. But if it's divergent, it's difficult. And from a consulting perspective, you know, looking at all of the, I think in sort of 4 levels and the 4 Ps: the philosophy, the policy, the procedures, and the practice. And so the philosophy is sort of really, hey, this is how we're going to do it. And then the policy is really the framework, and then procedures into your standard procedures, standard operating procedures. And then actually the rubber hits the road in the practice and how you do it. And sometimes, you know, how you do it and the policy and procedures don't match. But so looking at all of those, the papers that are out there, the white papers and the concept of operations, they all seem still very high level at the philosophy perspective. And it's quite difficult from when you're looking at all of those, trying to meld them together, because it's one thing, it's very hard to cost, right? We don't know what it's going to look like. We don't know which one's going to be the dominant one. So very, very difficult to cost, and I think it's going to be fascinating to see how that develops over time. Because, you know, now that we've got a stake in the ground, EASA and the FAA have to really knuckle or come together to decide who's going to do it. So what sort of moves nicely onto the ConOps for advanced air mobility. So Boeing and Wisk have published their autonomous UAM aircraft operations and the vertiport integration. Which outlines that high-level vision of what is how it's going to work. And I know that you've talked a little bit about that this morning, Catherine, and so it's really good. There's one part of it which is around the infrastructure that supports that. And Anna, you've done a fair amount of work in the area of looking at the infrastructure and how that sits within a transportation system. So I'm really keen to sort of explore how the infrastructure is going to be sort of generated, because you need the infrastructure for the system to work, but we don't know what the system looks like. So how do we create that infrastructure? And the other part of that is around, you know, the infrastructure to me looks really like a heliport, which we know about. So, you know, the Gen 6 Wisk aircraft is 100 feet, which is 15-ish meters, so D15 or D14, D15, so the D value is that. So can we create these bits of infrastructure like a vertiport that caters to helicopters, to various types of UAVs? So anyway, I'm sort of going on here a little bit about how do we plonk this infrastructure in the middle of a working city?
Yeah, I think that's a very, very relevant question. And I think by now people have noticed that that is one of the key building blocks to have a successful introduction of advanced air mobility. But I had the feeling that for years people tended to, well, think if we only get the technology working, then everything else is going to work as well. And I think by now people understand we're going to have to build vertiports that are going to have, or that have to fit into existing cities, as you say. And I think one of the points that is rarely mentioned is that, well, people always say we don't need a lot of infrastructure for advanced air mobility because we don't need roads, we don't need rail tracks, we don't need any of that. We just need a vertiport at one end and a vertiport at the other end of our flight. And I think if we then start making the math behind it, we see that, well, if we think just of a, well, medium-sized city, if we look at Wellington, for example, we have 500,000 inhabitants. If we assume all of them make 3 trips per day, that's already like a lot of trips every day. That's 1,500,000. And then if you say, well, we only take 1% of the transport trips that are conducted every day and we shift them to advanced air mobility, we're going to see 15,000 flights, which means we're going to see 30,000 takeoffs and landings. And we just need to think about what is the size of these vertiports really going to be? What are we really going to see there? And how much land do we really need? And what larger impact is that going to have? So if we build it into the city, we might just take away for housing, or we're going to, well, see effects on the land rents that we have. And I think that is something that so far is being discussed, well, not that much. And I think there's still a lot of space for that.
So, I mean, and when you talk about 15,000 flights, that's 625 or 625 people an hour, basically. And so that's a reasonable amount to move around. Where's the best place for putting these vertiports? Is it in affluent parts of the city? Is it in the business district? Where would you put them?
So you would want to put them where the people are most likely to use the service. And well, despite we assume it to be affordable, we still know that we're going, or that it's likely that we're going to see people with a higher willingness to pay for travel time savings to be more likely to use this service. So we're going to see people with high incomes using it, but we're going to, from them, also hear, well, we don't want to have that soaring above our heads. If I'm at home, I don't want to have a flying taxi above my head. So I think we're going to have, well, a large discrepancy in where we would need to have these vertiports and where we have inhabitants that accept to have these services close to them. So we're going to see them in business districts, which might not be much of an issue. But then if we think about, well, regions where people live, then I think we might end up we're going to see some problems, because we're going to have high income individuals using the service, where we might be flying above the heads of households with lower incomes that don't benefit at all from the service, and they're only suffering from the noise or from the privacy issues that we see if we have the aircraft flying above their heads.
Yeah, so I mean, that's 100, like we talk about the numbers that you were talking about before, was for the 625 pax an hour, which is around 156 flights an hour if we're using the Gen 6 aircraft, the Catherine. So we got to put this into those areas. Let's I'll talk maybe a little bit more about Auckland, because we understand this sort of city, the affluent areas, Mission Bay, St Heliers, Point Chevalier. Are they going to be happy about having the aircraft come in and out that many times, or it's more so, I suppose, down in right down in the heart of the city that the large number of aircraft are going to be coming in?
Yeah, no, this is an awesome topic, thinking about like infrastructure, vertiport location, where the routes go and stuff. A lot to unpack there. I guess the point I want to start on is the location of the vertiports and therefore the routes is very much a co-design piece. So I think what's really important, if you're going to picture a typical city, you're going to have Wisk, but then you're also going to have another provider who does cargo, and then another one that does medical and everything. And so there's standards, but there's also design where the city wants to take control of what are going to be these corridors in the future, where are the vertiports going to go, because that's going to have to tie in with the city's electrification plan, with the ground-based transport. So most cities, you know, if you talk to an airport, they've got a 50-year infrastructure plan. So, you know, over that time, you're not only going to build vertiports, you're also going to build train lines and bus stations and ferries. So, you know, there's that challenging piece of design, and it's quite nice actually, you know, talking with Ministry of Transport the other week, they're starting to think about, you know, what are the protected highways for the future? Like what is that future city design? So I think there's a real piece there that needs to be looked at. And as part of that, sort of in the early, we've covered so much in this little 5 or 10 minutes, but at the start you sort of talked about who would be doing this. So one of the things, Wisk and most of the OEMs are not planning to build their own vertiports, you know, so the idea is that there'll be vertiport operators who will offer service to multiple OEMs. So in the same way that you don't have a Qantas airport and an Air New Zealand airport, you'll have a vertiport that that services all companies. And I think that's a really important thing about maintaining equitable access to the airspace. So in that space, we see a couple of types of companies. We see standards companies. So Skyports will be in it. So Wisk has a partnership with a company called Skyports, who are also partnering with a number of other OEMs. And you might have seen that this week they opened up a sort of customer interface research facility near Paris. So a vertiport with just, you know, like a nice basic facility and a couple of pads, so they can start to explore what would those connections and processes look like. There's also some people, companies looking at this from a real estate investment perspective. You know, what are the, you know, locations that that companies are going to want to invest in and put a vertiport in the future and be able to extract rent and stuff from that. So there's almost like kind of a new industry to deal with there. And just in terms of the routes, and again at the start there was some discussion around sort of getting in and out of airports and the like. One of the things that we need to think about is that the early market entrants will be operating VFR. So obviously with a pilot, they'll just operate VFR and use, you know, a mix of existing and new traffic locations. But then as we go towards autonomy and we get into airspace design, so new types of IFR routes, and then towards DFR, there's an opportunity to look at, you know, where are we going to design in the routes that, you know, minimize nuisance or, you know, can be negotiated with the community, and that also can be delivered safely. So for example, eVTOL aircraft have a different approach and departure and missed approach profiles. So, you know, if you look at a typical missed approach at the moment, you know, it demonstrates a behavior that's, you know, suitable for fixed wing aircraft, but a missed approach for an eVTOL aircraft, you know, that behavior is likely to be quite different. And so you can start to look at different airspace design. So I think there's a number of, yeah, I'll keep talking. There's so many overlapping things here. You can see there's a lot.
Yeah, because the obstacle limitation surface in and around those areas are very difficult, especially in high-rise cities. And so now you're putting a vertiport, say, next to or adjacent to a large train station. And how do you integrate the obstacle limitation surface that, you know, there's nothing sticking up that they can fly into to protect those elements? Yeah.
Which roofs are suitable, all of that good stuff.
Yeah, so I mean, what you're sort of saying there is it's going to sort of drive. It's probably councils in some ways that are going to be driving where this is, and in consultation probably with the state regulator for aviation. And so there's going to be a lot of resources required there with sort of specialist knowledge. And one of the questions we've got from through the Q&A chat is they're interested to see if and how we see the resource constraints amongst the regulatory agencies, and I'll put that into the regulatory agencies and the local government, central government agencies, impacting the timeline and the roadmap for advanced air mobility. You know, maybe I might go to you for that one first, and then I'll let Catherine.
Yeah, so I think that's just a super difficult question because nobody really knows when it's really going to fly. And as Catherine already pointed out, it's just like development and planning cycles are just so long, especially in city planning. If we look into, for example, vertiport developments, we're going to have 10 to 15 years minimum until something like that is going to be built. That's at least for Germany. I think that's probably the worst that it can get. But yeah, so it's just super difficult. And I think it's hard for especially municipalities to understand when they have to take action, because it's difficult for them if they just start running behind what is happening, and whether if there's already a service and then they just then start following up behind, that doesn't really help anyone. So I think really everybody has to be prepared to, if it really starts flying and if companies start really offering services in the larger scale, that everyone's ready to really jump in and also.
Yeah, it's going to be, or I think the resources, and it's probably in the research game as well, that it wouldn't be many people of your knowledge and experience in there. And Kath, you're right in the heart of this right now, really, you and Wisk, to not just the certification standards and regulations, but then also with the planning. And I know that you're getting into Queensland as well, and looking at how your craft sort of fits into that transportation sector. So, you know, the resources that are available, the personnel resource in those different branches, are they available?
Yeah, so this is an interesting one, and one of the ways that we look at it is how to avoid regulatory overload, or the regulator receiving sort of similar but slightly different messages from each OEM or each developer, because that's not really helpful. So I think what's really positive is where there's programs like the FAA have a lot of working groups. I'm sure ES, I think ES has the same, and Wisk is involved on both sides of the Atlantic. And in New Zealand, we have the AITP. There's a number of emerging activities in Australia. And so anything that can have the industry players come together and sort of, understand the commonalities, and the regulator be able to say, most of the picture is held in common, and let's develop a standard or an agreement or whatever it is, and then let's just deal with what's different. Rather than each OEM or each certification having to be an entirely different, sort of built from the grounds up proposition. So that's why we think standards are so important, whether that's a vertiport standard, or what's the cert basis going to be for eVTOL in this country, or things like airspace integration, what's the detect, some missing bits, the detect and avoid industry standard, what is going to be the C2 resilience standard, all of those things. The sooner we can settle on standards and work through those together, the more it helps, because we could always do with more resource. But I think that would help the teams that are working on this problem, I think.
Yeah, I think you smashed that one in the park. That there is the absolute key to it, right? So you do those certification standards right across the boards, or the development standards, and then it provides the guidance. And all you have to do is, as an OEM or someone who builds the infrastructure, is come up and say, here are our plans that meets these guidelines, or these standards as well. So the JARIS, or the Joint Authorities for Rulemaking of Unmanned Systems, and there's the RTCA, the Radio Technical Commission for Aeronautics. You've got the EASA, you've got CASA, which sort of talked about the difference of or differences between EASA and FAA. Are they specific enough yet, or do we need more specificity in there? Or are we at a danger of being too specific and not allowing the sectors or the OEMs to develop in a sort of a framework that they think is safe?
I think the comment I could make at this stage is international harmonisation is the piece that would help us all. And so I think ICAO is now starting to become involved in AIM, which is a good development, especially in advance in the Asia Pac region, where you have countries that are dealing with both FAA and EASA. So I think rather than specificity, it's the international harmonisation that is the piece we are all that would move the needle for the industry more.
Yeah. So that means it sort of really has to come into something like ICAO, doesn't it? So
yeah. Or like CAA being or CASA, this amazing opportunity to mediate.
Yeah, to drive it already. Hey, so the biggest challenge with the introduction of advanced air mobility, just going to our poll. So we've got there's basically it's looking at certification standards, regulatory requirements, the infrastructure, public acceptance, user adoption, stakeholder alignment, or all of the above. We've got all of the above. Sort of a third of the answers are all of the above. Interestingly, there's nothing. No one's looking at public acceptance, which sort of really fits with the way that I feel about this system, in the fact that if you get the other parts right, the public acceptance will come along. The certification standards are sort of sticking out as the one that's got the higher number of answers or ticks for that. So an infrastructure and user adoption and stakeholder alignment, not that, stakeholder alignment is a massive massive issue. So let's move on to stakeholder alignment and the complexity of sort of combining all of these systems. And one of the terms that you use, Kath, is one of an ecosystem, and covered that off a couple of times. So would you like to just delve into the ecosystem from your perspective?
Yeah, sure. So we could kind of think about it like, layers of the onion. So if you start with the aircraft, which is something, always draws our eye and we're really familiar with, but even within Wisk as an OEM and an operator, we have the aircraft, we have a fleet operations system, so a ground system that's part of the certification, production certificate and operations certificate. So there's quite a few pieces to that, as well as staff on the ground in a variety of roles. But then you sit within the advanced air mobility ecosystem, where there's a number of actors that connect the platform to the environment around it, to the passengers. So one of these is a PSU, or provider of systems services, to UTM. So if we think about an environment where we've got a lot more activity going on in the airspace, where we've got pilots on the ground, and where we don't want to have voice-based analog control of the aircraft anymore. We want to have these digital 4D flight rules. We're going to need information, validated information, be flowing easily between the different OEMs and different operators, as well as the air traffic controller, the vertiport controller. So that's where PSUs come in, providing awareness and information. And that's a real nascent industry. There's a couple of players involved in AATP, but it's an area that's still developing. Then we've also talked about the vertiport. So you can imagine a vertiport operator is going to have different types of aircraft landing on it. They're going to be charging trickle batteries and fast charge batteries, and they're also going to need to have technical control of a vertiport, like a heliport, but perhaps a bit more like a warship deck, where an air carrier deck, where you've got a lot more frequent movements, like a fast jet line. So you're going to have that level of technical control of the vertiport as well. Then you're also going to need the communications infrastructure, so C2 links for the aircraft, connecting it to control and instructions, but also allowing communications if the passengers need to speak to somebody on the ground. And then of course, when you connect that with the city infrastructure, you've got electrification, you've got other passenger transport means. So really those benefits that the community are after come when all those elements of the ecosystem are put together.
Yeah, so it's an enormous logistics tail, right? And behind there, and I just sort of touch on for the infrastructure for the vertiports. You think about the power just required to power something like that, and then for the charging. And so the studies that have been done is that you need a power supply to cool the power supply for a vertiport, which is based on electric vehicles. So that sort of raises, you've raised a huge amount of parts to this in this ecosystem, which looks at the cost of this, and that sort of how does what are the charges going to be for the sort of passenger, and what are the business model options? And I know, Anna, you've worked on something for the business model options for the urban air mobility. So how do you see the costings and working and then working into those sort of those other, or combining all of those parts together?
Yeah, I think that's really going to be one of the main drivers, also strongly related to public acceptance, but also, of course, user adoption. So you need to make sure that you reach price levels where it's actually appealing for people to use it. And I'm not entirely sure how that is going to work in a system where you don't have sufficient demand, because I believe that you need a critical amount of people that really demands these services to make sure that you always have a seat load factor in your vehicle that is somewhat allows you to really decrease prices to a level where it makes sense, and that you also have sufficient service and sufficient frequency for people to really say, well, okay, I'll give it a try and I'll use it because I can rely on the service, and I can make sure that if I want to go to the airport and I need to catch my flight, that it's not going to happen that they're going to tell me, oh, well, you're the only one booked for that flight, we're not going to offer the service. So I think that is really a trade-off where we really need to understand, is that ever going to happen? And is it going to happen for a group of people that is large enough to really get the system going? Are you still on mute?
It was going to happen. My dog is in the background. I'm on a life sentence block, so it'll be barking at something that's just outside. So what I haven't seen any costings at all that have been sort of thrown out there that is sort of saying, hey, this is going to be the price point of transit between A and B, and so you do need where this is going to really take off is the high number of people moving between over a reasonable distance, but it's sort of across the standard transportation network, say, and where you have to change multiple, and using London as an example, there's the Circle Line, but if you can get out to the sort of northeast or the northwest, how do you sort of join those bits up in a way that you can accelerate people and cargo getting around that city and reduce the congestion, as Catherine talked about earlier on. And so then it becomes a really hard problem to solve, and I don't know if people are going to be really able to put the infrastructure in place with an understanding of how much it's going to cost at the end of it and how many people they're going to move. So it's going to be a swinging into and hoping for the best. Would you think it's like that, or is it going to be we're actually going to be able to get together and run a really solid project plan with a Gantt chart that's going to say, yeah, this is it, this is the return on our investment, and this is exactly where we should put our infrastructure and how the model should look?
So this is why Wisk takes a partnership approach. So we talk about, like, the importance. We've got a range of partners, Boeing, but then also working with cities and working with skyports and working with other vertiport operators. So we do think, there's a bit of work ahead of us, but we have a plan, and the plan, includes a range of infrastructure and operational partners in New Zealand, for example. But also in terms of the price point, like looking out and having a plan for as we move towards scale. So if you think about these platforms coming into market, initially they'll be operating at small numbers while we prove the supervisory ratios to the regulator, etc. But then as familiarity and as design increases, you increase the scale, and that's when you start to reach that price point of sort of the Uber Black, Uber X type of transit cost, which is what we're targeting. So the intent is this is going to be something that's affordable for most of the population, perhaps for a airport transfer on a holiday or accessing a particular event or a hospital or something like that. So it's intended to be accessible to a wide range of the population. And that's part of the story behind autonomy or self-flying as well. Because that allows us to scale. Obviously, there is a global pilot shortage. Pilots will always be a super important part of aviation, but that's going to be complemented by self-flying. And also, interestingly, when you start to dig into electric engines, and reduce levels of maintenance, and all those kinds of things, actually, there's a range of ways that this becomes a more affordable, over time, an affordable form of transport.
Yeah, high capital cost, but low direct operating cost is really what you're going for there. And so the infrastructure is massive capital cost as well, isn't it? Yeah. That's a great element about it, and I think so in my brain, what we've been talking about is sort of one of moving people around, but is the opportunity more so or equivalent in the moving of parcels and cargo or freight in and around the city? Is that the same, if not a bigger opportunity? What do you think, Verena?
Well, I think it offers an opportunity, and I think the risks are just way lower because, well, the aircraft are likely to be less heavy, so there's going to be less impact if they come down. And in addition to that, well, we don't have people on board, so it's also, well, less risky. But I'm not entirely sure how well that matches with the overall aims that we have in transport politics. So what we're seeing currently is that we're trying to develop cities more towards walkability, bikeability, public transport, all kinds of green modes of transport. And if we now start taking all kinds of cargo into the air, I don't know how well that matches. I do agree that there are application cases, for example, blood samples or medicine transport into regions where you have low infrastructure density. I totally agree, and I totally see the value that we have there. But in general, I'm a bit skeptical, and well, that also holds for passenger applications, I would say. But yeah.
A bit skeptical. You're skeptical that all of the needs are going to be met by this technology.
That it can be met, and whether we should be aiming for that.
Right, and is that purely from an environmental aspect?
Yes, mainly from an environmental aspect, because
And
I mean,
sorry, talk me through that.
I mean, it's irrespective of what kind of energy source you use, you're always going to need more electricity or energy to lift things off the ground. Of course, if you have much shorter routes, you're going to probably save some energy, but if you have a somewhat similar distance that you can cover on ground, be it by electric cars or be it by public transport or be it by rail, then you probably should rather aim for a different mode of transport. And I think that is something that we should have in mind, because electricity or energy in what way soever is not for free. That is what we currently, in the current crisis, especially notice.
Yeah, so certainly in Europe, the energy prices are up. So in your PhD and in your papers, you sort of looked at which benefits people most preferred. It was time, so talking about congestion versus the amount that they pay for the service. Which one did people favour?
Yeah, so in fact, it was interesting to see that if you really start looking into the time savings in detail, it's not for all the trips that you really have the opportunity to save time. So you have to think about, well, we're talking about these vertiports, and we've been talking a bit about the locations for these vertiports, but we haven't talked about what are you going to do to get to these vertiports to really start your trips. You're going to see access and egress trips, and we all know, well, if we live in a big city and we don't have it far to the railway station, then it's fine and it's convenient to go by train, because then you just walk there or you take a bus and it takes you 5 minutes or 10, and that's fine. But if you live in rural regions and you need to go and take your car and then drive 30 minutes to the next rail station, then it's just like very, very difficult to really make this work. And I think that is something where we really need to understand what is the density of the infrastructure that we're going to see, and what are access and egress times to the infrastructure. And then we're not even talking about possible security checks that we might be seeing. While they're not mandatory, at least in the European setting, I know that, but well, we're likely going to see them in the longer run, I believe. And then all of these steps require time. You're going to plan for some buffer time, and I think that is something that also needs to be considered. And then you pay a premium to not really save time, but to overfly congestion. And I think, yeah, that is an important trade-off.
Hey, look at it, and the great thing is we really won't know until we see it, right? So Hey, I'm going to sort of finish off with one final question here for you, Kathy. When are we going to see this?
Awesome. So the key thing here is it depends on the regulator. So the environment has to be ready. The aircraft have to be certified. The airspace integration environment has to be ready, and the regulator has to be ready. And so we're starting to see around the world some regulators start to come out with their view of the timeline for this. So, for example, the Aotearoa draft aerospace strategy has a goal of fully integrating autonomous flight by 2030. So that's really exciting, and other countries are coming up with timelines, some a bit later, such as in Europe. So really what drives the regulator. But the other one is that you're going to see this kind of staircase, this phased approach where UAS like Swoop with this medical missions and all those things, that sort of thing will continue to increase and embed into our systems, and then you'll see the piloted platforms come, and then you'll see the autonomy. So there will be, we're not just going from here all the way to here, all the way up here. There's definitely that phased approach to allow us to step through the challenges, which I think is an important part of the journey.
So regulators are key, certification standards are key, the use cases are really fascinating, and the value that society is going to bring from use cases you articulated nicely, Anna. So I'd like to massive thank you to you, Anna, for dialing in from the other side of the world at 2 to 3 o'clock in the morning. And I don't know if I could string sentences together as eloquently as you have at this time of the hour, the circadian rhythm. So look, thank you to you, and thank you, Catherine, for giving a great perspective and sharing your knowledge with us about how Wisk is going and the sort of greater advanced air mobility system. So thank you very much.
Thanks, Scott. Always love to see you. Thanks, Anna.
Yeah, thank you.
Awesome. And just a final check of the poll. Nothing really has changed their certification standards and problems with all of the above. So look, fabulous. Hey, look, we look forward to the other ones, and I'm sure there'll be a bunch of people watching this afterwards on video as well. So thanks very much to both of you, Anna and Catherine, and I'll take you back to UAVNZ.